We're going to talk about inheritance and polymorphism in Java. So, introduction to inheritance. When you hear the word inheritance, code may not be the first thing that springs to mind. You're probably more likely to think of inheriting genetic traits like eye colors from your mother or a smile from your grandfather. But inheritance is also an important feature of object-oriented programming in Java. Suppose we are building a shape class in Java. We might give it some points in 2D, a method for calculating the area, and another method for displaying the shape. But what happens if we want a class for a triangle that has some triangle-specific methods? Do we need to redefine all of the same methods that we created for shape? No. Luckily for us, a Java class can also inherit traits from another class. Because a triangle is a shape, we can define triangle so that it inherits fields and methods directly from shape. The object-oriented principle of inheritance saves us the headache of redefining the same class members all over again. There are several terms you'll encounter frequently: parent class, superclass, and base class refer to the class that another class inherits from, like shape. Child class, subclass, and derived class refers to a class that inherits from another class. And in this case, we have the example of a triangle. Okay. In the instructions, it says to take a look at the image to see how inheritance works in object-oriented programming. So what we can see here, we can see a class called task, and it has some fields, description of type string, and isComplete of type boolean. It also has a method called toggleComplete, and it has the parentheses. So this tells us it is indeed a method. So this is a parent class. And if we want to create another class called deadlineTask, okay, we can see that deadline task, this class, inherits the description and the isComplete. It inherits them from the parent class, okay? But it can also have fields and methods of its own, okay? So for example, in this case, isOverdue is a method that is defined within the child class, yeah, but also this class, the deadline class, because it inherits from task, it will have also the toggleComplete method as well, okay? And this is what we can see here, inherited. We're going to go to the next lesson. Let's have a look at the inheritance in practice. So how we define a child class so that it inherits from a parent class. We use the keyword extends like this. So we have a class called shape, okay? And we would have some class members. If you remember class members, when we hear this word or this expression, it means that is referring to fields and methods defined within our class, okay? So class members are all the fields and the methods, or fields. I think we've referred to them previously as instance variables, okay? And now here on this line we have another class called triangle, and triangle extends shape. So shape is this class. This is another class, and it uses the keyword extends to inherit whatever functionality and fields from the shape class, okay? Now triangle has inherited traits from shape. So our triangle class has inherited from shape, meaning that it copied over class members from shape, okay? So whatever we would have defined here inside, inside class shape, they would have been inherited in the triangle class because it says here extends shape. Okay. Until now, we've only been working with one class and one file. However, most Java programs utilize multiple classes, each of which requires its own file. Only one file needs a main method, and this is the file we will run. We have a note here: the various classes in our Java package, even though they are in different files, will have access to each other, so we can instantiate one class inside of another. If we have a look at the instructions, it says you have two files: noodle.java, this will house your parent class, and spaghetti.java, this is where you will build your child class. The noodle class has already been defined for us, including the length in centimeters field, the shape field, the texture field, and a cook method. Okay. Then in spaghetti file, spaghetti.java file, we have to create a class called spaghetti. So class spaghetti. Okay, so we've created a class. Then tab back over to noodle.java to run your code. We always need to run our program using the file that contains the main method. Okay, so we've defined here, we've declared the class spaghetti, which is empty at the moment. Now if we go back to the noodle.java file, so this is our class. We have class noodle. Okay, we have some fields: double, length in centimeters. We have a string shape. We have a texture, of course, of string as well, which already has a value inside. We have a method called cook, and this method is void, so it does not return anything. And in here, we're saying this texture, so is referring to this, it gets set, so this field gets set to the cooked value instead of the brittle as it was before. Okay, and then of course we have the main method. Okay, alright, so tab over to noodle.java to run your code. We will always need to run our program using the file that contains the main. Fine. Let's run it. Okay, and we don't see anything because there's nothing in the main method, okay, to be executed. So we've completed this instruction. We go to instruction number 2, and it says tab back over to spaghetti.java and make spaghetti a child class of noodle, if you haven't already. So to make spaghetti a child class of noodle, we have to use the extends keyword that we've seen, so extend keyword, followed by the class that we want our current class to extend from. Okay, so let's run this. Now we've completed instruction number 2 as well. If we have a look at instruction number 3, it says tab back over to noodle.java. In the main, instantiate a new spaghetti object called spaghetti pomodoro. Okay, so remember how we can instantiate a class. Well, we have to use the name of the class. Okay, spaghetti. We have to call it spaghetti pomodoro like they said to us, and we have to use the keyword new to create a new object. Okay, and in this case we're gonna have it says instantiate a new spaghetti object. Okay, so we have to use the spaghetti like this. Okay, this calls the constructor of the spaghetti class. Okay, let's run this. Okay, so it says your code should print brittle in the output terminal. Well, of course, we haven't. I didn't get to read the whole requirements of this task. So what we need to do is to print out the texture to the field terminal. So we do say system.out.println. Okay. I'm gonna increase the font a little bit to make it a bit easier to see. And now, how do we access the texture field? Well, we say spaghetti pomodoro dot texture, and this thing is only possible because at the end of the day, this object called spaghetti pomodoro that we've just created is of class spaghetti, okay? Is of type spaghetti. But in here, you can't see any texture, okay? But, so inside the spaghetti class, we can't see any fields declared. But because our spaghetti class extends noodle, then it means that now spaghetti, any object of type spaghetti, will have access or will inherit all the fields and all the methods that were declared in the class from which they extend from, okay? So if our spaghetti class extends from noodle, then any object that we create from the spaghetti type will also have all the variables and the methods declared inside our noodle class. That's the reason why we can here on line 15 say the variable that holds our object, okay, that refers to our object, access this. So on this object, access by using the dot notation, access this field, okay. So if we run it here, we get brittle on the screen, and our task number 3 is completed as well. Okay, let's go on to the next section. It says inheriting the constructor. Hang on, you might be thinking, if the child class inherits its parents' fields and methods, does it also inherit the constructor? It does indeed, and sometimes this isn't quite what we want. Okay. Now, let's say shape has a numSides field that is set by passing an integer into the constructor. If we're instantiating a triangle, we would want that number to always be 3. So we'd want to modify the constructor to automatically assign numSides with a value of 3. How can we do that? As it happens, Java has a trick up its sleeve for just this occasion, using the super method, okay, which acts like the parent constructor inside the child's class constructor, okay. So if you remember previously, we had a shape method, and now we have the a shape class. So we had a shape class, now we have a triangle class that extends our shape class, okay. And this is the constructor of our class, and it says go to the constructor of my superclass and call that. So with the super, it's gonna call the constructor of the parent class, okay. By passing 3 to super, we're making it possible to instantiate a triangle without passing in a value for numSides. Meanwhile, the super, so this super method behaving as shape, okay, will shoulder the responsibility of setting numSides to 3 for our triangle. It is also possible to just completely override the parent class constructor by writing a new constructor for the child class. Okay, so how do we override a parent class constructor? Is by defining our own constructor, okay? So we say triangle here with a parentheses, and this is the constructor for our triangle class. And inside this, we say this dot numSides equals to 3. NumSides is a field that is inherited from shape. Okay, so somewhere where the shape class was defined, we would have a numSides field of type integer. And here in the triangle constructor, we're saying this dot numSides equals to 3. Okay. So whenever we create an object of type triangle, it will automatically have the numSides field set to 3. Okay. And the above example, numSides is just set to 3 without leveraging the parent class constructor. If we have a look at the instructions, it says tab over to fo.java and build a constructor for fo. Okay, so as you can see, we have the noodle class, okay, that has some fields. It has a constructor of its own. It's making use of the parameters that are passed in the constructor, okay, to set the values of its own fields. And then we have the method called cook, and is a void method. And then of course we recognize the main class, the main method. So if we go to fo, it says to build a constructor for fo. Okay, what we can do is to just use the name of the class and followed by the parentheses and then these curly braces, and it says leave the constructor's parameters blank. Inside the constructor, pass the following arguments into the following order to super, okay, the constructor for noodle. Okay, so if we're gonna use super, okay, like so, we have to, let's have a look again at this. Okay, so we have to say 30. Okay, we're gonna say 0.64. We're gonna say flat. Okay, and because this is of type string, then of course we'll have to use the double quotes, yeah, to show that it is a string indeed. And this one, the ingredients, would be rice flour. Okay, let's run this. And task number 1 was completed and we're not getting any errors. So let's have a quick look. Why does this work? Well, it says this class. So we have the class fo, okay? And the class has to have a constructor, okay? And because our class called fo extends noodle, okay, then the constructor defined inside of fo has to match the constructor, the explicitly defined constructor in noodle. Why? Well, because fo extends noodle. So therefore, whenever we're gonna create an object of type fo, it will automatically run the constructor defined in its superclass, in the class from which fo inherits from, in our case being noodle. But if we have a look at the constructor that is defined inside of noodle, it's taking some parameters here, okay? So it's not just a simple constructor, just called noodle and the parentheses. It's actually a specifically defined constructor that takes some parameters here, okay? And the values that those parameters are taking are then used to assign values to our instance fields, so to our fields here, okay? That's why we have to do this. So we have to pass, we have 1, 2, 3, 4. So 4 arguments in total. 2 of them are of type integer, or this is an, well, type double actually. So double, double, and then the other 2 are of type string. So we have double, double, string, string. Okay. Now it says task number 2. Tab back over to noodle.java inside the main. Instantiate So inside the main, instantiate a new faux instance called faux chai. Okay, so we have to say the name of the class. Okay, so we have to instantiate a new faux, okay, called faux chai. So that is the name of the variable that is going to refer to our object, okay. And we say new faux, okay. So tab back over to noodle.java. Inside the main, instantiate a new faux instance called faux chai. Now print out faux chai's shape. So if we're gonna do this, one second, we have to of course print out. So system.out.println, and we have to say faux chai dot shape, because it's telling us to print on the screen the shape. Okay, and in this case we're getting flat. Well, why are we getting flat? Well, because this is how the object is created, okay? Because we've hard-coded these values inside our super here, okay? So inside our faux constructor, we've passed it some hard-coded values, okay? We can go to the next section. It says parent class aspect modifiers, okay? So you may recall that Java class members use private and public access modifiers to determine whether they can be accessed from outside the class. So does a child class inherit its parents' private members? Well, no, but there is another access modifier we can use to keep a parent class members accessible to its child classes and to files in the package it's contained in, and otherwise private. And this access modifier is called protected, okay? So, for example, if we have a modifier, so these are the modifiers. Sometimes they are private, sometimes they are public, okay? And these determine whether other classes can access these values, okay? Or interact with them. And now we've just been introduced to a new access modifier called protected. So here we have a table that explains to us what does each access modifier do. So we have the public access modifier, which makes everything that a class contains, it makes it available to other classes, makes it available to any classes that are in the same package, makes it available to any child classes or to any other classes that are extending our class, okay? And global is the same. Well, global probably in the same package, okay? Protected, and this is the one that we're looking at now. So protected will be gives access to our fields and methods to any other class, to classes in the same package, and to classes that extend the class in which these fields with the access modifier protected have been defined. Okay. No modifier means, so for example, if we would have no modifier there, it would mean that any other class could access this, and any other class in the same package, okay? But no child classes will be able to access this one. Okay, and then private, well, private means that the fields and the methods declared within a class as private, so with the access modifier of private, they will only be available to that class, okay? So here's what protected looks like. So the access modifier protected. We have a class called shape, and we would define a field called perimeter of type double, and the access modifier for this variable will be of protected, okay? So any child class of shape can access perimeter. Okay, because it's protected, and if you can see here in our table, it says that protected means that any child class of our main class, of our base class, or of our parent class will have access to this field because it was declared with a protected access modifier. In addition to access modifier, there's another way to establish how child classes can interact with inherited parent class members using the final keyword. If we add final before a parent class method's access modifier, we disallow any child classes from changing that method. This is helpful in limiting bugs that might occur from modifying a particular method. Okay. So if we have a look at the instructions, it says currently noodle has an ingredients attribute or a field that its child class ramen cannot access because it has a private access modifier. Okay. So we have a noodle that has an attribute called ingredients, which is this one, okay? And the class called ramen here, which extends noodle, cannot access, okay? So our ramen class here cannot access this field called ingredients, okay, because it has a private access modifier, because the ingredients variable or field or attribute was declared with an access modifier of private, okay. Change the access modifier for ingredients so that ramen, not just any Java file in any package, can access it, okay. So in this case, if we have another look here at the at this table that explains to us what each access modifier allows us to do. So let's read again. Change the access modifier for ingredients so that ramen, not just any Java file in any package, can access it. Okay, so let's see. So change the access modifier for ingredients so that ramen, not just any Java file in the package, can access it. We're gonna set it to protected. Okay. Let's run. Okay, so why protected? Well, because protected means that any child class, okay, can access it. So therefore, if ramen extends noodle, it means that ramen is a child class of noodle. And by making this protected, it means that we're allowing the ramen class to have access to this field, okay. So in task number 2, it says noodles has an it's tasty method that returns true because noodles are tasty. But if you check in the ramen class, you'll see someone overrode is tasty to return false. That person clearly doesn't know food. All noodles are definitely tasty. Remove the method from ramen and add a final keyword to is tasty method in noodle so that nobody changes this method in any other noodle child class again. Okay, so what it says is because this method here called is tasty on line 18, because it was made public, then it can be accessed by our class ramen, our child class that extends Noodle. And what we can do is we can either keep the same definition, okay, but since we are defining it again here, whatever we put inside means that it's gonna override the definition. So it's gonna discard whatever was defined as here, and it's gonna stick to this one. So it says to remove the method from ramen. So we're in the ramen class, we're gonna remove it, okay, just gonna comment it out. And then we go back to Noodle, and we have to add a final keyword to it's tasty, yeah, is tasty. So public final, okay, so that nobody changes this method in any other Noodle child class again. Okay, let's run it. Yes, we have added the final. Remove the method from ramen and add a final keyword to is tasty in Noodle. Yes, we have done that. Why is it giving us a well, maybe do we need to delete this one? Yes, so we have let's delete this one altogether. Okay, let's go back to Noodle, public final. Did you add the final keyword to is tasty in Noodle? Yes, we have, haven't we? I don't know why it's giving a an error here, because we have added the final keyword. It turns out that this final keyword needs to be added before the access modifier, because it says here if we add final, so the final keyword before a parent class method access modifier, so the access modifier is public, so therefore the final keyword needs to be added before the access modifier. Okay, and now if we run it, there's no errors. Okay, we're gonna move on to the next session. It says Introduction to Polymorphism. In Java, if orange is a fruit, through inheritance, you can then use orange in the same context as a fruit like this. So say we have a method, make juice, that returns a string, and we're passing it a fruit variable of type fruit, and we say return apple juice, and so we do a concatenation here with fruit.squeeze. So we call the squeeze method on this fruit parameter here. Okay, so inside the main we could say orange. So imagine we would have an orange class, and we're creating a variable that references to our orange object, okay, and of course it's going to be of type orange. And then on this line we say system.out.print juicer, okay, dot make juice. So we would have created an object juicer, okay, dot make juice. This is the name of our method of an orange. Okay, wait, how does that work? This is because Java incorporates the object-oriented programming principle of polymorphism. This word derives from Greek meaning many forms and allows a child class to share the information and behavior of its parent class while also incorporating its own functionality. The main advantage of polymorphic programming is to simplifying syntax, reducing cognitive overload for developers. I can't agree with this. Cognitive overload for developers, like at the moment, even this code here doesn't make too much sense because it's so out of context, okay? Like juicer, you can't really see where juicer was actually, you know, instantiated here. So then you can make it, you know, call this method make juice on it. It's just, it's a bit jumbled up, but we'll see as we go, okay? So these benefits are particularly helpful when we want to develop our own Java packages for other developers to import and use. For example, the built-in operator plus can be used for both doubles and ints. To the computer, the plus means something like add double, okay? For one and well, to the computer, the plus means something like add double for one and add int for the other. But the creators of Java and of other languages didn't want to burden us as developers with recalling each individual method. Note that the reverse situation is not true. You cannot use a generic parent class instance where a child class instance is required. So an orange can be used as a fruit, but a fruit cannot be used as an orange. So this is very important to remember. So because fruit is more generic, orange is more specific. In our case, fruit is a class and orange is a class. I would think that orange extends fruit, okay? So whenever we are required to pass in a fruit, we can only pass in a fruit, okay? Whenever we are required to pass in an orange, we can either pass it an orange or a fruit, okay? So an orange can be used as a fruit, but a fruit cannot be used as an orange, okay? If we have a look at the instructions, once you feel ready, click next to continue. We feel ready? I think we feel ready, okay. The next section, it's talking about method overriding, okay. Overriding a method means writing it again. So for example, if in this class we have a method that says hi and it prints on the screen hi, if this other class extends noodle, okay, and of course we understand by now that if this class extends the noodle class, then everything that was defined in noodle, so all the members of that class, including fields and methods, are going to be inherited by this class. So if in this class, if in the noodle class, we defined a method called hi that prints hi on the screen, then the same method will be present in this class as well. But what we can do is we can override. So instead of the same method called hi, yeah, the name of the method that is hi, instead of it to return hi, we can override it to return or to print on the screen hello, okay? So I'm sure we will see some more examples here and actually get to type them as well. So one common use of polymorphism with Java classes is something we mentioned earlier, overriding. Overriding parent class methods in a child class, okay? So like the plus operator, we can give a single method slightly different meanings for different classes. This is useful when we want our child class method to have the same name as a parent class method, but behave a bit differently, okay, in some way. Let's say we have a bank account class that allows us to print the current balance. We want to build a checking account class that inherits the functionality of a bank account, but with a modified print balance method. We can do the following. So we have a class called bank account. We have a field called balance of type double. And then we have a method, a void method called print balance, okay? And this method doesn't take any parameters. And this method will print on the screen your account balance is balance, okay? So it concatenates this text with this value, okay? And it's gonna print this whole thing on the screen. Now here we have a class called checking account that extends our bank account, okay? So if it extends our bank account, it means that it inherits everything that was defined within our bank account class. And then it does something new here. You can see this notation at override, okay? And we can see we have a method, a public void print balance, which if you look, and it's exactly identical to this one, public void print balance, public void print balance. System.out.print your checking account balance is plus balance. So essentially it does pretty much the same thing, but the actual output, whatever is going to print on the screen, is different. This one says your account balance is, and this one says your checking account balance is, okay? So this is how we override a method. So a method that we inherit from a superclass, so from a class that we extend, we can override it, meaning we can provide a different implementation, okay? We can have it to do something a bit different. And the way we do that is we have to keep the same definition here, the same header, okay, of the method. We use the at override notation, okay? So at override starting with capital O. And we have to give it some sort of a different implementation. So the body of this method needs to be different from the body of the method initially defined in the parent class. Because otherwise, if we were to give it the same exact content, then there wouldn't be any point of using the override or to actually put it here at all, okay? Notice that in order to properly override print balance in checking account, the method has the following common with the corresponding method. So in bank account, it has a method name. Yeah, the method name is print balance. The method name is print balance. The type is void. The type is void. The access modifier is public. The access modifier is public as well. Okay, so the method name, the return type, and the number and the type of parameters. In our case, it doesn't take anything, okay? It doesn't take any parameters. You may also have noticed the override keyword, so this one here, above the print balance method in checking account. This annotation informs the compiler that we want to override the method in the parent class. If the method doesn't exist in the parent class, we'll get a helpful error when we compile the program. So say if we actually do this, yeah, but in here we don't have any, so think that this is not here, the print balance method. If we were to run this code, yeah, with this highlighted method completely missing, we will get some sort of an error that will inform us that the method does not exist in the parent class. Okay, so therefore we don't need to use the override, the at override notation, because we're not actually overriding anything since the print balance is not even there in the first place. But this was just an example of what happens if we use this annotation when we don't actually have a predefined method, okay? So going to the instructions, it says noodle. So the noodle class has a cook method that involves boiling the noodle and changing the texture to cooked, okay? The German noodle dish Spätzle, I guess, involves a slightly unconventional cooking procedure, grinding or scraping the dough in the pot of boiling water, okay? In this Spätzle Java file, we need to override the inherited cook method, okay? Copy the original method body, but before boiling gets printed, add a new line to print grinding or scraping dough. Okay, so we're gonna copy this, Okay, let's have a look at this method. Okay, so we are in the noodle.java. So in our noodle class, we are interested in this method, the cook method. Okay, and it's telling us that before we print this, okay, so before we print boiling, we have to add a new line that says grinding or scraping the dough. Okay, don't forget to add at override above the method to help with debugging. Okay, so what we need to do is we need to go inside this other class, the spatial class. Okay, and is giving us here some notation, some comment that says, okay, add the cook method below. So we need to go inside the noodle class. We're gonna copy this whole method. Okay, we're gonna paste it here. We have to add at override notation, okay, because this method cook was already defined in noodle, but we want to change it, we want to modify it, we want to give it a different body. Okay, so inside here we need to add, so before printing boiling, we need to add this line of code. So we want to print out this on the screen, grinding or scraping dough. Okay, so because we have actually changed the body of this method, now we shouldn't be getting any errors because we have added the at override notation. Our class indeed extends the noodle class, so therefore it inherits the cook class, but because we're not happy with just this definition of this method, we are gonna take the same method, okay, but with a different implementation, with a different body. And what is different is that we've added this line of code here. If we're gonna run it, it says grinding or scraping dough, which is this one, and then boiling, which is this one. Okay, and also it has changed the texture. Okay, so the texture, instead of brittle, it will be cooked. Okay, let's go on to the next section. Using a child class as its parent class. Okay. An important facet of polymorphism is the ability to use a child class object where an object of its parent class is expected. So this is like the example we talked in the previous section, where we said if we have a fruit and an orange, if we have some sort of a method that would require a fruit, we can only use a fruit. If we have a method that requires an orange, given that orange extends the fruit class, then in that method we can pass it either an orange or a fruit, okay? But it can't be the other way around. So one way to do this explicitly is to instantiate a child class object as a member of the parent class. We can instantiate a checking account object as a bank account, like this. So we have a bank account, okay? So thinking that checking account is a class and banking account is a class. But checking account extends bank account, okay? In this case, if we want to create a new object, and this is where the new object of type checking account is created, we can store this object in a variable of type bank account, okay? Because bank account is more general. Checking account is more specific, more specialized, okay? But checking account is a type of bank account, okay? But it's not vice versa. Bank account is not a type of checking account. It only works one way, because checking account extends bank account, okay? So that's why that's the only way we can do bank account here. Otherwise, we would have had to use checking account. So checking account, this name here, new checking account of 600, okay? But because checking account extends our bank account class, we can actually use bank account Kyla's account, okay? And then instantiate the object as a checking account. Again, because checking account extends the bank account, okay? So this is the parent class, this is the child class, okay? Okay, we can use Kyla's account as if it were an instance of bank account in any situation where a bank account object would be expected. Okay, so we can use this account as if it were an instance of bank account in any situation where a bank account object would be expected. This would be true even if Kyla's account were instantiated as a checking account, but using the explicit child as a parent syntax is most helpful when we want to declare objects in bulk, okay? It is important to note here that the compiler just considers Kyla's account to be any old bank account, okay? So Kyla's account is of type bank account, but can hold an object of type checking account because checking account extends the bank account. So checking account is a child class of bank account, of this parent class. But because method overriding is handled at runtime, if we call print balance, we'll see something checking account specific, okay? So because we declared, if you remember, we declared if we have the print balance method that was defined initially in the bank account, okay? And of course, if checking account inherits the bank account, of course now the same method, print balance, is going to exist in checking account as well. If we don't override it in the checking account, then of course it's going to have the same body as the method declared in bank account. However, if we are overriding the print balance method inside the checking account, and remember we would have to use we would have to add the @override notation on top of the name of the method, okay? Then it will print, okay, the output of this balance, or the body of this print balance method will be checking account specific, okay? Will be checking account specific. It will have the body we defined for print balance inside the checking account if we've done that, if we've override it, yeah? If not, it will have the body that we defined for print balance in the bank account class, okay? Your checking account balance is this, okay? This is because at runtime, Kyla's account is recognized as the checking account, it is. So what if checking account has a method transfer to savings that bank account does not have? Can Kyla's account still use that method? Well, no. The compiler believes that Kyla's account is just a bank account that doesn't have some fancy child class transfer to savings method. So it would throw an error. Okay, so let's try and read this again. So what if checking account, which we determined would be a class, so what if checking account has a method transfer to savings that bank account does not have? Can Kyla's account still use that method? No, okay. So in our case, whatever methods we've defined in our bank account, we can call on this variable here, okay, on the variable that references our object. However, the specific methods that exist only in checking account that do not exist in bank account cannot be accessed by this variable, okay? So apparently so. Because the compiler believes that Kyla's account is just a bank account that doesn't have some fancy child class transfer to savings method. So it would throw an error, okay? If we have a look at the instructions, it says if you take a look at the at the dinner class, you'll see that there's a makeNoodles method that accepts a noodle object as an argument. Okay, so we have look at the dinner class, and it says it has a method, a private method of type void, so it doesn't return anything. makeNoodles, okay, and it takes a parameter of type noodle called noodle, a parameter called source of type string, and okay, so that's that, and it says noodle.cook, okay, and then it says mixing. Well, it does some concatenation here, and then it prints dinner is served. Okay, we have our main method as well, so we have the type of our variable that's going to store our object here. Okay, and we have to add some code, but let's read the instructions. So if you take a look at the dinner class, you'll see there's a makeNoodles method that accepts a noodle object as an argument. In the main method, we have to instantiate an object of this name. I don't know why Codecademy is using these very weird names and biang, okay, and so many others. You know, they could just add to the simplicity, really. So we have to create an object. Instantiate an object as a noodle called this. Oh dear. Okay, so we have to say new like this. Okay, and we can do it like so. Noodle. Okay, now we haven't had a look at the noodle or this class here. Okay, but I'm expecting that this class will extend noodle, okay, because otherwise this code will not be correct. Okay, so there you go, we have this one that extends noodle. Okay, so therefore we can say in the dinner class, we can say, well, I want a new object of type biag, and this is going to be the name of the variable that refers to the object, but the overall type of this variable is going to be of type noodle, and this is only possible because this class, okay, well, this class extends noodle. Okay, okay, then call makeNoodles on noodles dinner with the following arguments. Okay, so we already have noodles dinner here. Okay, so we have to say noodles dinner, and we have to call this method makeNoodles, okay, with the following arguments. So we have to pass it this, okay, and then this. Okay, so if we have a look here, it's gonna say a noodle. So when we call the makeNoodles method, is going to expect two arguments, one of type string, okay, and one of type noodle, okay. And because we have this one here, type noodle, okay, but we can instantiate it as an object of type biang, then this means that we can pass this object here, or this variable here, we can pass it into our makeNoodles method, because it's expecting our makeNoodles method is expecting an argument of type noodle, yeah, which we do have here, this one. Okay, so let's run it. Well, I haven't added the semicolon at the end. Okay, and we're getting, of course, the output coming from here, mixing the cooked noodles made from high gluten flour, salt, water with soy sauce and chili oil. Dinner is served. Okay, let's go on to the next one. So the next section, child classes in arrays and array lists. Usually when we create an array or an array list, the list items all need to be the same type. But polymorphism puts a new spin on what is considered same type. In fact, we can put instances of different classes that share a parent class together in an array or an array list. So for example, let's say we have a monster parent class with a few child classes. A vampire, a werewolf, and a zombie. We can set up an array with instances of each, okay? So we are here declaring some, we're only declaring, so pay attention to this, we're only declaring some variables. One is called Dracula, the other one is Wolfman, and the other one is Zombie 1. And all of these variables are of type zombie, of type monster, sorry. Okay. And we say Dracula, so this variable, is gonna hold an object of type vampire. This object, Wolfman, is gonna hold an object of type werewolf. And Zombie 1, this one, is gonna hold an object of type zombie, okay? New zombie, so it's using the new keyword here to create new objects of each of these classes, okay? But this is only possible, so whatever happens on the next line is only possible because all of these classes, vampire, werewolf, and zombie, are inheriting from the parent class monster, okay? Therefore, we can say we have a variable called monsters that holds an array of monsters, okay? Of values of type monster. And we have Dracula, Wolfman, and Zombie 1. We can even iterate through the list of items regardless of the subclass and perform the same action with each item, okay? So for monster, and we give it a variable. This could have been M, this could have been I, it could have been anything, okay? So for each element in our monsters array, then monster attack. Given that attack, this method would be defined in the monster class, okay? And the code above, we were able to call the attack method on each monster and on each element in our monsters array, okay? Despite the fact that in the for each loop, monster is declared as the parent class type monster, okay? Now, if we have a look at the instructions, it says declare and initialize an array of type noodle called all the noodles with the following items: spaghetti, ramen, and pho, okay? Alright, so declare and initialize an array of type noodle called all the noodles with the following items. So we say noodle, all the noodles, and it's gonna have these elements inside: spaghetti, ramen, okay, and the other one will be pho, okay. So we have this parent class, okay, class noodles, noodle, and then we're expecting that all of these three classes are extending the noodle class, okay? So extends noodle, extends noodle, extends noodle, okay? Then here in the main, we're declaring these variables, spaghetti, ramen, and pho, okay, of type noodle, okay? And we then, in each of these variables, we store an object of type spaghetti in the spaghetti variable, of type ramen in the ramen variable, and of type pho in the pho variable, okay? But because all of these three classes are inheriting from the noodle class, this is the parent class, then we can create a an array, okay, of type noodle called all the noodles that holds these values, okay? If we're gonna run it, did you create a noodle array? Well, yeah, but we have to do this. Okay, yeah. In task number 2, it says loop through each noodle in all the noodles. Call get cook prep method on each noodle and print the result. Okay, fine. So what we need to do here, we can use a for each loop, yeah, like we've seen here. So for noodle n, okay, in all the noodles, because this is our array that contains all the elements. What do we need to say? So we say n. So call the, we have to, the system dot out dot print ln. Okay, so we have to print the result of get cook prep on each of the elements inside our all the noodles array. Okay, so we say n, this one, the name of the method. Okay, let's have a look. Get cook prep. This will print on the screen boil noodle for 7 minutes and add sauce. Okay. Oh yeah, well, of course, because the get cook prep, of course, is gonna be overridden here. Yeah, in each of them, if you have a look. Yeah, hence is gonna get for each type of noodle. Okay, for example, for the spaghetti, it's gonna go to spaghetti and check this method. Okay, the get cook prep. Okay, that was declared here because it's using the at override, because this method is also defined inside the parent class, the noodle. Okay, but it has a different implementation here. So therefore, if this method is inherited from the parent class, then of course, if you want to, inside the child class, if you want to give it a more specific or a different implementation, then of course you want to use the at override notation and then use the same header of the method, but instead provide it a different body or a different implementation. Okay. Okay, so we're ready to move on to the next lesson and the last one. So this is the review of inheritance in polymorphism. So we've learned quite a bundle about inheritance and polymorphism. A Java class can inherit fields and methods from another class. Each Java class requires its own file, but only one class in a Java package needs a main method. Child classes inherit the parent constructor by default, but it's possible to modify the constructor using the super or override it completely. You can use protected and final to control child class access to parent class members. Okay. Java's OOP, so this means object-oriented programming. So Java's OOP principle of polymorphism means you can use a child class object like a member of its parent class, but also give it its own traits. You can override parent class methods in the child class, ideally using the @override keyword. It's possible to use objects of different classes that share a parent class together in an array or array list. Okay. Let's have a look at the instruction. In the code editor, you'll find a parent class called Noodle and some child classes to play around with. We invite you to experiment with what you've learned about inheritance and polymorphism. Okay, let's start the quiz. And I'm gonna continue this quiz in the new lecture.